All right, so today we're going to start with notes 9-2, and yesterday we talked about proportions. Today we're going to talk about similar polygons, which end up being proportions. We may not see that so much today, but we will in the future. So let's start off with the definition of similar polygons. Polygons that are the same shape but different sizes. So maybe I've got a triangle here, and maybe the angles are, I don't know, 40, 60, and 80. Well, I can have a similar triangle that has the exact same angles, but it's just bigger. So maybe this is 40, 60, and 80. So the same shape and angles, but they have different sizes. So if two polygons are similar, then two things are true. And by the way, the symbol for similar is a tilde. It's like the thing we put over congruent, okay? So if two polygons are similar, then their corresponding angles are congruent. Just like what we had up here. These start off to be similar because they have the exact same angles. If the angles were different, then they wouldn't be similar. They also have to have corresponding sides that are proportional. Because like these up here, well, they're different sizes, right? So maybe the lengths are 1, 2, and 3. Well, then maybe over here, they're 2, 4, and 6. So if I was setting up proportions, well, they're all just multiplied by 2, so they're all the same. And we'll get more into that later. For right now, let's see if we can name some things. So it says, use the figure below, or the figures below, to answer the questions that follow. So we have our similar symbol here. That means these two are similar. That means all the corresponding angles are congruent, and all the corresponding sides are proportional. So if I look at angle A, and these are orientated in the same way. Angle A is right here, so the corresponding angle on the other side would be in the same position, so it would be angle X. I have side BC. Well, this is side BC over here. I probably shouldn't put that. This is side BC over here. I'll just put a question mark. Well, the corresponding side to that would be this one over here, which would be segment YZ. Then we have angle B is up here. Well, the corresponding angle to that would be in the same relative position, which would be over here, which is angle Y. I have side AB, which is this one right here. Well, the same corresponding side would be right there, which is segment XY. And it makes the last two pretty easy. If this is C, the corresponding angle would be angle Z. And then our last side would be this angle, or the side AC or CA, which would correspond to segment XZ. Okay? Now, these triangles are orientated the same. I could flip them upside down. I'd have to give you a little more information, but they don't have to be sitting in the same place. Okay? Like I could make this triangle be sitting on XY down here, and we could still do this. Don't worry about that yet, though. This one you might have to just a little bit. If the quadrilaterals below are similar, then what must be true? So I know that the angles have to be congruent, the corresponding angles. Well, this one gave me some markings, so I can do this pretty easy. I know that angle A is congruent to, and if I look, this one has just one line right here. Again, I shouldn't write that. Just one line right here. Well, then that means it corresponds to angle E. Then I have angle B, which is congruent to angle F. I have angle C, which is congruent to angle, it looks like G. And then I have angle D, the last one, which must be congruent to angle H. So pretty easy on this one. Now let's talk about the sides. You can kind of start from wherever you want. I'm going to go in alphabetical order. I start off with segment AB. And when we say things are corresponding, let's use these dots right here. That's going to be corresponding to side EF. And notice that the angles are the congruent angles surround that side. So A and E were the same, B and F were the same, so that means those sides are corresponding, which in this case they're proportional. Then I have my segment BC, and that's going to be corresponding to, it looks like FG. I have side CD, which looks like it's going to go with side GH. And then my last side would be DA or AD, it doesn't really matter, would be the same as HE. Okay? So it's pretty easy. You just got to pay attention. Don't go too fast. You'll accidentally write something wrong. Let's look at the next page here. Now, this one doesn't give us a picture. It just tells us that triangle LMN is similar to triangle RST. So similar, remember, is that symbol. So I'm just going to sketch it. So maybe I have L, M, N, and that's similar to, and I'm going to go in the same way, R, S, T. So it doesn't necessarily, you could label them different, but remember, this is kind of, this statement right here is telling us what goes with what. Like L is the first letter, that means it goes with R. M is the second, it goes with S. N is the last, it goes with T. So those statements make it pretty easy. But other than that, it's the same thing. It looks like L and R are going to be the same. So angle L is congruent to angle R. M and S look like they're the same. So angle M is congruent to angle S. And then the last one would be angle N is congruent to angle T. But again, you can go back up to the name and you can see that L was with R, M was with S, N was with T. And it sort of works the same thing with the sides. L, M are the first two letters. That's one segment. Means RS is going to be the corresponding side. So I'm going to have segment LM is going to have to be corresponding with side RS. And then the next two letters are MN. That means it goes with ST. So NM with ST. And you could have done MN also. Sorry, I did that backwards. And then the same thing with the last ones. N goes with L and T goes with R. So NL and TR. But remember, these are segments, so the letters could be flipped, and that's still just fine. Now, the last thing we're going to talk about today is the word included, and this is pretty important in similar polygons. An angle is said to be included between two sides. Also, a side is included between two angles. So let's look at this first example, and maybe you'll see what I mean. It says, use the polygon below to answer the questions that follow. It says, which angle is included between side AB and side BC? Well, those two connect at this angle here, so the angle included between them is angle B. The other way you can see this is notice what both of these segments share is B. That means that's the included angle. We can do that another way too. If we want to look for the side that's between angle E and angle D, well, that has to be side ED. And if you notice, if you take the two angles and put a line over them, that gives you that included side. So it says which angle is between AE and AB. So AE and AB would obviously be angle, whoops, not angle B, angle A. Sorry, and that's the one they both share. So you might try to do this last one real quick before I do. You can pause for a second and try it out. So I hope you did try it out, and if you didn't, oh well. I'm looking for the angle included between AM and MC. Well, they both share the M, so that's angle M. Name the side included between angle A and angle M. Well, that's going to be segment AM. And then name the side included between angle A and C would be segment AC. So if you have any questions to this, definitely we can go over it in class, but I hope that works for you, and you should probably start getting to work on your homework. Good luck.